we do? Can I give you a, by the way, this is section 6, I believe, not section 7, if my counting is correct. So I want to give you like a big picture before we kind of finish out the class with the last 3. Regardless of what you think about what you've done with MATLAB so far, by far the most important possible thing you could take out of here is how to bring data into MATLAB and then what to do with it. Okay, so there's some little secondary things with the statement I just made. Number one is, well, how do I bring data? We've already seen this fancy import data thing that helps you. And then the reason I emphasized structure and matrices so much is because if you, understanding that, you will know, once the data comes in, what is it in MATLAB? And now you know, it's a matrix. It might be a vector, a row vector, it might be a big matrix of values, but it's a matrix. Okay? And then you've learned, now we're learning some things that you can do with it. I say all that to say, is it possible you will never again in your life write a function? Yes, it is possible. Does that mean it's not important? No. Especially if you're concerned about your grade in the class. It is important. I'm just trying to give you a rough comparison of the concepts in this class and how important they are. So let me say all that in slightly different words. We really needed to talk about the very most important things we could do with MATLAB in slightly the middle of class. To get there, which is importing data, its structure, and some things that you could do with the data. MATLAB should be your tool, a friend, your calculator, etc. To get to that point, we needed to do some introductory stuff such as emphasize the matrix structure, addressing, and so forth. And then writing functions is an important way of doing slightly more advanced things. So people can use MATLAB without ever writing functions. They could analyze their data without doing that. But if you know how to do it, you will be able to take it one step further. Okay? And then finally, from here on out, we're going to be talking about slightly more advanced features of MATLAB. Stuff that you might be even slightly less likely to encounter as you go on in engineering, but that's okay. There's lots of things that you do in classes like that, right? You'll still be graded on it. Okay? So, Lily, based on what I've said so far, should a student space out now? No. Why not? You sure? We'll be graded on it, right? Do all things you ever learn in college, might you encounter them again after engineering school? No, that's okay. Okay, with that little intro, let's get right to it because it's freezing. Kudos to you for being here. Look at this full class. That's great. I did not want to come either. I was rooting for the snow day, just like you. On the other hand, then how would I have satisfied my need to be amidst such fine students as yourself? Oh, I would have been able to. So this is all right. Okay, let's jump into it. So far, we have talked about, we're going to be doing some slightly advanced addressing. Two things today. Slightly advanced addressing and subfunctions. They're pretty separate things, so I will try and make it clear when I'm making that break. All right, so first of all, slightly advanced addressing. Now, first of all, we need to talk about logical arrays. We already have, actually. It's a matrix whose elements are true or false. So, for example, if we have, let us just go to MATLAB and do that. Okay, define a crazy vector. Should I make that slightly bigger? Let's do that. Did I change it? No. I wasn't sure. How about that? Okay. Yeah, here we go. All right, I got a random vector here. Which of these are divisible by 3? You know how often you want to test if numbers are divisible by 3. Well, a remainder function or a modulo function would do that. So well, I'll show you something. I'll type it in there and explain it. This is where order of operations becomes important. Okay, I'm actually making an assignment on a logical operation. Myself, I actually would never type it this way. I would actually, because I get confused very easily, so I would probably do something like this. And now we can sort of talk about it. The right-hand side says modulo A3 is equal to 0. That will return what? A logical vector, which is true if the modulus really is 0, and false if not. Okay, so I won't even put a parentheses there and do it. And what do I have? B. What is B? The answer to anything. What is your response is? A matrix. Good. What type is B? That's right, it's logical. So I should put, class is already up there. Let's just move this over so we can see it. Okay. Oh, I want that like that. Okay. Okay. So far, so good. We actually did something like this, or very close to it last time. Now I show you something interesting. If I say A, B, what is this doing? I am doing an advanced form of addressing. I'm asking for the values of A, the elements of A, for which B is true. Okay? That is what I'm doing with this statement. So if I hit return, notice how it picks out the first one because that's a true, 2, 3, the third one because that's a true, and so on, the 7th and the 8th. Okay? So that's lesson number 1. I can do something called logical indexing. Now, the elements, which are, let's take a moment and think about that again. A was of type numbers. Actually, the real thing is we call it, say, double. A was a double. B was a logical vector. How about that last thing, A of B? Well, that's just returning the elements of A which are true in some sense. The elements of A themselves are doubles, so that is of type double as well. Okay. Let's come back here, which are divisible by 3. We did that. What's returning? Oh, I kind of combined 2 slides into one. That's okay. B is a logical vector, class logical. I did this, but in this case, looking at what is mod A2 equals 1 means what if I have a remainder of 1 if I divide by 2, which is like which of these numbers are odd. A of B is not a logical vector. Okay, questions there? Yes?
So can you just repeat the equal 1 part, what you said that means, the mod A, 2 equals 1?
Oh, yeah, okay. Mod is like remainder. So remainder of each of those elements divided by 2. Do I have a remainder of 1 or not? If I don't, it's 0. So if I have a remainder of 1 but dividing by 2, it means it's an odd number. How's that? Okay. Excellent. Excellent question. What else? What else? All right. Let's make it slightly more fun here. Come back. Make a new A. 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay. Now, if I say B equals A greater than 5. Now, for self for self-genius points, don't hit return. Work through this with me. Once this completes, what is B? Matrix, right away. What type is B? It is logical because it is a logical operator on the right. How about what size is B? 3 by 3. It's got to be the same thing as A. Okay, good. So sure enough, B is the same size as A, and it's showing. By the way, remember, are there really 1s and 0s inside of B? No. That's just how it's displayed to us, right? There's really trues and falses inside of B. Now, what happens if now this is really getting up, 90% of you would never see this again. That's okay. What happens now if I do A index B? That's a very strange thing to say. It is going to return the elements of A for which B is true, but the big question is what will be its structure? Because we're all about structure and organization. What will be its size? So for this kind of thing, let's hit return and see. Notice how it's a column vector. Okay. So what has happened? What has happened is MATLAB doesn't really know how to process a matrix, a real matrix with more than one dimension on it, or a dimension greater than 1 on each side. So what does it do? It goes through linear index wise, picks out the trues, and returns those. So in other words, it loops through B 0, 0, 1, 0, 0, 1, 0, 1, 1. It does the same thing here. 7, 8, 6, 9, and puts them in column vector form. Okay? So really the only strangeness or weirdness about this is it doesn't really know how you want it returned, so it returns it in column vector form. All right. Yep, okay, did this, good, 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 and good. If 90% of you might never see something like that again, then why talk about it? I am hoping that you at some point will be analyzing data sets which are a little more complicated and which, if you take to heart the savviness of what MATLAB can do for you, will make things very, very easy. So here's an example. We've got a 3 by 3 matrix. Let's say we've got a 3 by 3 matrix that's given to us. We want to take the elements which are less than 5 and take their square root and replace it in that matrix. And the elements which are greater than 5, we'd like to square and replace it in the matrix. Don't ask me why would you want to do this. I don't know. But barring a better way, a better example, what's the brute force way to do this? You would loop through all elements of the matrix. You would ask if they're greater than 5 or not, less than 5 or not, and then do the appropriate things. So in the case where you've got a two-dimensional matrix, you might have an inner loop and an outer loop and say, okay, for 1 to 3 rows, for 1 to 3 columns, if that element is less than 5, then replace that element with the square root of that element. Otherwise, here's where we want the else, then replace it with the square of that element. And the if, and the inner for loop, and the outer for loop. Okay? Nothing really wrong with this. Okay? But any questions about how it works? Like, why does this do what's written on the board? All right, let us explore a slightly savvier way then of doing this. Let's see. A contains this matrix that I want. Okay. I'm interested in doing something with particular elements and in particular the ones that are less than 5. Okay. So B equals A less than 5 returns true in those positions where it's really less than 5. Now, I show you something interesting. A of B means for the elements where B is true, I would like you to replace that with the square root of those elements. So this one bears slightly talking about, okay? Start on the right-hand side. A of B are those elements which are true. The square root of those elements, it's going to be 4 numbers. Wait, 4 numbers? What's less than 5? 4 numbers. And it's going to put that right back in the same exact locations where A of B is now. The fact that A of B in both places returns column vectors is okay. It's all right. It doesn't mess with the structure external to this kind of savvy indexing. Okay? So boom, with one step, we replace all of those elements with their square roots. What if I want to do something with the other ones? The very fact that we have now a logical matrix to work with gives us a nice way to flip it. Do we have a logical operator which turns every true into false and every false into true? What is it? That's right, squiggle. Its real name is not. And some people call it tilde. Whatever. Oops, not exclamation point. A tilde B equals A tilde B. And now I need the point caret squared because I'm doing a vector squaring. Okay? So just some savviness to keep in mind. I have a student right now who is working with a data set for which there are 1 million rows. And they're all needed. They're all important. And there are several columns. Being able to do something with all 10 million numbers with one thing, with one command, is powerful. You really wouldn't want to loop through 1 million times. That would take a lot of time. Okay, questions. What time is it? It's time to go home. I know. For me too. Wonder what Mrs. Bashford is thinking about for dinner tonight. know you'd have to do that, right? Oh, son. My kids are horrible. They're wonderful human beings, but sometimes they send me horrible things. Let's move on before we get into that any further. Okay, we did this. Here's the matrixized code. Very savvy. Very nice. Leave that on for a second so it's captured by the video. A closely related command is something called the find command. Find simply finds the indices of an array that are not 0. Okay. If you take find and try to use it with an array of type double, it will tell you the locations, not the elements. So when we were doing these other vector logical operations just a minute ago, it was returning back to us those elements, the doubles, the scalars, that met a certain logical condition. Find gives you the locations, the indices of some logical condition. Okay? So if you use find with a vector, which is doubles, it tells you the indices which are not 0. You can now again, find A gives us the locations of what's not 0. So what is returned to us? Well, index number 1, 2, 3, 6, 7, 8. 1, 2, 3, 6, 7, 8. Love it when things work out. Now, I didn't assign it to anything, so what did it get assigned to? ANS. What is ANS? A matrix. What type is ANS? Doubles. And that makes sense. Indices are, you might have more than true. You can't have indices that are true or false. Indices need to be countable things. Okay, so now I look at the notes and ask what wants to be done. There's a slide that says statements can be made short. I'm going to rename that slide on the fly and say this slide should say how to make your power go too far. what can you do that might start to get you into the sort of unreadability thing? Let's say you have a matrix like this. And I want to take all of the, like before, I want to take all the elements which are less than 5 and replace them with the square root. I don't want to define an intermediate logical vector B. I just want to do it in one line. You can do that. You can say A, for the elements which are less than 5, okay, just that all by itself, look, inside the argument is a logical vector, really, A less than 5. And I want to say that's equal to the square root of the elements of A which are less than 5. Okay. Very nerdy, very powerful, might have taken it too far. It works. I love it. It's great. It's sassy. Is it readable? I don't know. That may be one, if you were going to do this in a function for some reason, you might just go back and put a few intermediate steps in there, like define a logical vector or something, so you can see what's going on. Okay, questions. That's the end of one big. You may. When I say this, don't say, "Oh my word, are we only halfway done?" Don't say that yet. That's the end of one of our big sections today. Now we need to do the other, but that's going to go fairly quickly. Okay, so any questions on what we've done so far? Let us talk about subfunctions then. Oh, okay, well, I just lied. Well, no, I think I said this. Key result. When you're addressing a matrix A by another matrix B, so I want the elements of A of B. What does that mean? Well, if B is logical, it means give me the elements for which B is true. And if B is a double, it means give me the elements of A, treating B as indices. Like if B was 3, 4, 5, 6, then A of B says give me the elements of A3, A of 4, A of 5, A of 6. Okay, so that is all we've done in a nutshell. Subfunctions. You could put more than one function in a file. You know, if you were on hell, if you got bored, I mean, you were writing your function, you know, for a homework or something like that, it was boring you to tears because it was so dang easy. You can put more functions within that function, and we'll call those subfunctions. And you can nest them as much as you want, okay? So I'm just anticipating your boredom. I know you want to write a whole bunch of subfunctions. This is what you do. Subfunctions look just like what we'll call primary functions, but I sort of made up that name. A primary function is what we have done up to this point, maybe the outer function. But they can't be accessed outside of the, actually, you know, before I say too many words, can I say that after I put all these words on the screen, it'd be much better if we just go to functions with a subfunction and look at them. So that's what we'll do. You know, yeah. I can come back to this if necessary, but right now it's just craziness. I just need to get to an example. Nothing says it better like an example. Okay, so I've given you this .m file in your Blackboard. And how many times am I going to do that? Every time. Whatever. Your online thing. I've given this to you, and you can look at it. And, you know, I'm sorry, but these kinds of illustrative examples you would never write in the real world because they're so short. It doesn't matter. What does this thing do? It takes in an input vector called x data, and it's going to calculate an average and a standard deviation of those. Never mind that you could just type mean of x data and std of x data within the command window and get it like that. We had to write a function to do it. But we're just demonstrating what subfunctions are about. Okay, so x equals, I'll try and think of some random. By the way, if you try and think of random numbers, you can't. That's just a little random comment. pun intended, for you today. Whoa. This average, this standard deviation equals my statistics x. Oh, I need to go in and stop it. I'm going to go set a breakpoint at the very first place I can. Boom. No, I don't want to do that yet. Sorry. Let's just run it. Return, okay, the function does what you think it does. It calculates the mean of those 1, 2, 3, 4, 5, 6, 7, 8 numbers and the standard deviation of those 8 numbers. Great. Let us take a slightly closer look at what is going on. All right, so I set a stop in the debugger. Always nice to do. And it's done. It's stopped. I know because of the green arrow. Now, from last time, what should be true up here? If I hover over my average, I see nothing. Why? It hasn't been assigned yet. I haven't set my average equal to anything. Same with my standard deviation. But if I go over to X data, yeah, it's there. Because it was an input argument. And as soon as I started running the function, that was passed in to the function. Great, so far so good. Is num points defined yet? No, because the arrow says this is the next thing that will be executed. Hasn't executed yet, so I need to step once. And now, num points is 8. How wonderful that MATLAB could help me count to 8, that complicated vector. But I'm very happy. Okay, now here's where it is key. Again, yes, the example is something you normally wouldn't do, but it's illustrative. This next statement takes a new function called myAverage_function. Where is myAverage_function? It's right down here. It is within my, what I've called primary function. Okay, so now there's a few things to say. There are a few things to say. First, if you have subfunctions in your function, they are defined exactly like any other function. Look at the syntax is exactly the same. Function, output argument equals function name, input arguments. Number 2, you can have as many subfunctions as you want. Number 3, MATLAB automatically knows where the start and end of any primary or subfunction is just by where you place these function definitions, okay? So as soon as I wrote function something equals myAverage_function, it knows because it's within the primary, it is a subfunction, and it knows that immediately above that, that was the end of the primary function. So if MATLAB gets to that point, it knows it's done and you can exit, okay? So it just makes it a convenient place to put it. There are 2 subfunctions because I have another function equals my standard deviation function. And again, MATLAB knows that it starts where it says function and it ends when there's no more statements to execute, okay? So in subfunctions, there's no need to put an end or a return or anything like that. It knows what to do. Now, that's number 1. So I want to go slightly, I wonder if you have any questions before we go on. There's a few more things to say, of course. Okay. Let us review slightly where we're at. If we go back and look at the workspace, we see num points and x data. And again, that is because we are no longer in the base workspace. We are in the function workspace. At this point, when I'm debugging, I have a choice. I can choose to go ahead and dive into the subfunction. If I know the subfunction is fine, maybe because I debugged it already 100 times before, I might just skip over it. If I want to skip over it, I would just press step again. But if I want to jump into it, I would do this little step in, kind of like we talked about last time if there's a function defined within a function. So if I step in, what happens? Notice this arrow turned white. It means you're no longer really at this point, but you have entered a new world or workspace. And there it is. And now I'm within the subfunction, my average function. If I go up and look at this function call stack, that's a fancy way of saying order of workspaces, I can down click on it and see that I'm actually 2 workspaces within. If I come back to the command window, I see that I've got new variables here, and that's because those are the variables that exist in that subfunction. Okay, so far so good. Just like regular functions, let us go back and look at how I called it from line 32. I said my average function, x data, and num points. That doesn't match how I wrote the input arguments on my average function. That's okay. They don't have to match at all. They just have to match in format, number, etc. All kinds of little interrelated things I can say, so I'm just going to keep right on going and saying them. You need to stop me as soon as you don't understand. If I go back up here and hover over x data, nothing happens. Why? I know you all know the answer. Who is brave enough to say it? You're not in that workspace. Exactly. So for MATLAB's purposes, it doesn't know right now what x data is and what num points is. However, it's down in the sum function, and it knows exactly what x and n are. Okay. So notice this is calculating the average. How do you calculate an average? You sum everything up and divide by the number of points that are in there, and that next line does exactly that. If I hover over MA, nothing's there. Why? Hasn't executed yet. So I step. Now it's executed. And MATLAB has a little behavior it does in functions when you're debugging. When it's done with the function, the last line, and you click step, it doesn't immediately return or go back to where it was. It gives you one last chance to, I don't know, that's not really. It puts a little down, it changes the arrow to green. All that means is MATLAB says, I'm done. The next time you press step, you will move to another world. Just in case you wanted to do anything with the variables in this world, do it now. I talk to myself and tell me what I think MATLAB is doing, you know. I'm sure you do too. But you don't have Mrs. Bashford looking at you funny while you're doing that in your den. But that's okay. I hope it's something like tacos or enchilada or something. We need to get going because I'm thinking about tacos. Wonder if I texted her and said there are tacos possible tonight, what she would do. I'll tell you what she'd do. She'd say, you darn gonna eat whatever we make. And by the way, why aren't you here cutting up stuff from, yeah.
What is the white arrow versus where stuff is?
Yeah, okay, so the white arrow means this is where you just came from, but you're not there in that workspace. But this is where you will return to. The green arrow, if it's pointing to something, says that's the next statement that will be executed. And if it's down, it means I'm done with all the statements in this function or subfunction. Your next step will return you back to the white arrow. How's that? So let's do that. Let's step. Let's watch the magic when we, no, let's not, okay. I say step, see what happened? I went back to the white arrow, it turned green. If I go back to the subfunction where I just was and put my cursor over X or N or MA, nothing, because I'm not in that workspace anymore. If I go look at the command window, not there. Now something interesting is MATLAB, this is just a little quirk of MATLAB. I thought that MATLAB just went through the subfunction and assigned my underscore average. Well, it got there and it returned the value, but didn't actually put it in my average. One more step and it does it. Okay. All right. There's another subfunction called my standard deviation, which is right down here, which we don't need to belabor because I think you get it. But look at what it does. It finds the sum of the squares, takes the square root, divides by n minus 1, which means it is an actual sample standard deviation rather than a population standard deviation. If you don't know what I just said, don't worry about it. It's standard deviation. Let's say that I believe totally that my standard deviation works. Okay, so I hover my cursor over it, nothing happens. I don't need to go into it, so I'm just going to step. It magically did it really quick. My standard deviation is now defined. And for a genius point, I've got a down green arrow right in the middle of this .m file. What does that down arrow mean? That is like a general, this is true. That's like a general statement. If you go one more step, it's going to jump to another, let's revise it and say, it's going to jump to another workspace. Okay? So now you are correct. Let's expand that even, make it even more specific. What's going to happen? That's right. Why? There's nothing else to do. It's the last statement before the subfunctions. This is the last statement in the, that means it's last statement in the M file within the primary function. I hit it one more time, step, and it should exit. Now, a lot of things happen at once. Number one, look at all of my continue step, all this, and the quit debugging. As soon as I step one more time, it knows I'm done debugging. It returns to the base workspace, and it takes away those buttons. That's a very helpful thing to know. See that? Because if you don't see those buttons there, you're not debugging. That's why it's important to notice that. Okay. Any questions on that? All right, I want to talk about the assignment just briefly because you're going to have questions. 30% of you don't be this class. Yeah. On hell, this is kind of like BSEN212 with, or 311 with the whole derivative thing in the parentheses. I said everyone's done this for 23 years. Okay. So for many years, I have described what I'm about to describe to you, and I think roughly maybe 30% of the class, not your class because I'm talking about past classes, the class didn't listen or got confused, which is okay. And then they came back and asked me something which I said specifically, don't do this. You're going to be the class that breaks the mold. I just have faith in you. Okay? What is that thing I'm about to tell you? Let's go look at the assignment. Boy, there's a lot of words on this. Start now. Ask questions well before the due date, which means, I mean, do you know what time I go to bed? Not that you should. I'll give you but a hint, like I'll bracket it for you. It is not at like 11:15 p.m. I know you're just getting started. I've been asleep for a long time. Okay. So, yeah, but I get up, yeah. So, you know, when you say to me, hey, let's get together at 11:30 at night at Brewski's, I say to you, you meet me at 4:30 in the morning at Mojave, and we'll talk. Yeah.
For 2 hours before you read my email?
What's that? Yeah, maybe. When you're doing MATLAB, you know, wherever you do it, I'm asleep. But you should still, you know, many of you have sent me wonderful pictures and benefited from it. So that's excellent. Okay. I do not, I know. I'm thinking about like tacos or something like that. So actually, Mrs. Bashford and I, one of our favorite things to do is cook together. Okay. Love cooking together. I mean, that's just like the best. Okay. So around this time, we're going to start thinking about cutting and chopping and slicing. And I have to hold myself back to talk about root finding, but I might because, you know, it's such an exciting thing. So enchiladas and root finding. A way to interpret root finding, if you have some curve, like this, a root of that curve is the solution to, all right, and where's that? Oh, I see it, it's right here. Okay. There is a numerical method to find roots. Now, of course, if you know the analytical form of f of x beforehand, you take a derivative. No, what would you do? Sorry. I'm mixing too many things there. I'm sorry for the last 20 seconds of your life. Forget what I just said. You're solving f of x equals 0, so maybe you can, if f of x is something like a polynomial or something simpler, you can just do it with algebra, right? Let's say f of x is much more complicated. Has logarithms and, you know, hyperbolic tangents and who knows what in there. Okay, so what do? There's a numerical analysis method by which you start with a guess. And if the guess is reasonably close, you iterate through a series of steps to become closer and closer and closer and closer to the actual value. And the way it works, you will look at, you know, in the flow sheet that is given to you. But I'm just going to kind of roughly give it to you. You calculate the slope. Oh, I made that one. That's like hit it on the nose. I didn't want to do that at all. How can I do this? Like that. Okay, there we go. So crazy function. There's the real root. Let's say you guess up here. You calculate the slope at that line. You calculate how far off you are. Oh, you're way far off. Then there's a little algorithm to move that guess that you had to another guess. And now I'm not drawing this to scale at all, but then you do another slope and it gives you another root, which is wrong. It tells you how wrong you are. That gives you another guess, and et cetera, et cetera, et cetera. And you can see that the way it's working is eventually it's going to get you very close to that real root. And the way you tell, am I close enough, you have to also provide to the function. You would call it the accuracy or the tolerance. So you might say, as soon as I'm within 1/1,000,000th of a unit, I'm close enough. Okay, so that is the root finding technique that we are practicing. You're going to write a function to accomplish this. I am going to tell you the things you want to do and the things you don't want to do. Okay? You can read many of these steps yourself, so I'm not going to read the whole thing. I'm just going to kind of jump to what you want to do. The whole point is to practice subfunctions. Okay? You want to write a subfunction that will calculate the value of f of x and the value of the derivative of f of x. And you're going to do this for two separate things. One is a polynomial. The other is something that has a natural log in it. I forget. That doesn't matter. So you're writing two M files. And with each M file, the subfunctions will be slightly different. Okay? Never fear. It's not like you're writing two completely brand new functions you got to worry about. Only one little line in the subfunction is different. Okay? So that's one thing. Taking that a step further, if the subfunction calculates the value of a mathematical f, you might, nah. Maybe it's called function calculate f. In each of these cases, you're going to be given the explicit form of the function. So for example, let's say on pencil and paper on the assignment, the function was x squared plus 2x plus 3. I made that up. In your subfunction, you're going to write something as simple. Remember, it needs input arguments, and it has some output argument that you're going to give it. You're going to input a number, or maybe it's input argument of x. You're going to return into the output literally that. So you're literally going to type in, my output variable equals x squared plus 2 times x plus 3. Okay? So what I'm saying is you're going to be giving an explicit function, two of them, and in each case you're going to literally put that into your subfunction. You're also going to write a subfunction which calculates the derivative of that function. Okay? You do the derivative on pencil and paper, and for both it's very easy, relatively easy. And then you explicitly put that in your subfunction. So what's the derivative? I can even do this. It's after 5. I'm thinking about burritos, and I can still calculate. I mean, now we're rocking and rolling. That's the derivative. So I might have a new subfunction down here, function calculate. And I know I'm writing sloppy. Calculate derivative. You're going to explicitly put in here output variable equals 2 times x plus 3. Okay. This will keep you from trying to do something you should not do. You should not try and use something we haven't talked about in class, the symbolic toolbox, SIMS, to calculate the derivative for you. No. You do all your calculation of derivatives on pencil and paper, and then you plug those expressions directly into the subfunction. Okay? It's a lot of words. Questions so far? What else do I need to tell you? Those are the main things. So you're going to be the first class that does not turn in something that has symbolic or sims or diff. Really uses subfunctions and really uses input arguments and output arguments. No inputs, no prompts, anything like that. Questions? If you have any questions about today's assignment, is there an assignment due today? Yeah, okay. Any question about today? We'll stick around for a while. And then it's off to burritos with Mrs. Bashford. I can't wait.